My name is Salomon Brys. I come from Paris. You can follow me on Twitter, although I do not tweet a lot. Very rapidly also, 6 months ago I created a company. This company is called Coding Coders. It is entirely dedicated to Kotlin. We're the first European company to be certified by JetBrains for Kotlin training. So if you need anything Kotlin related, please feel free to contact us. Now, we all know Kotlin rocks, right? If you're in this room, it's because you understand what Kotlin is. This is not a talk about Kotlin. We all know the benefits of using Kotlin, especially over Java on Android. Who here knows that Kotlin was actually developed to be a better language for Android? Okay, this was a trick. In reality, JetBrains did not develop Kotlin for Android. It was out of their own frustration, and as it happened, this frustration was particularly well spread amongst Android developers, especially because we were trapped on Java 6. But Android was not developed especially for Android. And in fact, in March of 2017, Kotlin 1.1 was released, and JavaScript support for Kotlin was deemed stable. JavaScript support for Kotlin was developed with the language at the very beginning, but when they released 1.0, it wasn't stable, so they decided to put it aside, so they could release the language for the JVM and for Android. But as soon as the first version post 1.0 arrived, JS was stable. So JS was a target for Kotlin very, very early on. And in fact, it's only in May of 2017 that Kotlin for Android was announced, officially supported by Google. So JS arrived on Kotlin before Google even said the community that Kotlin is a great language. So the idea that Kotlin will go everywhere was deeply rooted inside JetBrains, right? It's not a new thing that they are going into because they need to grow up. It's something that they've thought through from the beginning. And the language, the Kotlin language, was actually designed to be publishable everywhere. From the beginning, they thought about how to create a language that will spread everywhere. So, why Android? Okay, I'm not sure I need to explain why we need to create an Android app. We all know that Android is the first mobile OS in the world. So, okay, next question, why iOS? Yeah, which is a question I ask myself very often. And as it happened, if you want to live and make money, well, you need to focus also for iOS. So there's no need to explain why we're going on Android and why we're going on iOS. But the next question, this talk is about Android, iOS, and the web. So the next question that arises is, why mobile web? Why PWA, progressive web apps? Okay, why isn't Android and iOS enough? Because as it happened, we're not alone in the world. And in the part of the world where we cannot reach at the moment, forces are at work because this is the next big market. But that next big market won't probably be reachable via Google Play or via iOS. Okay, you want to deploy in China, you can't do it via Google Play. You want to deploy in India? Well, there's Google Play, but there's also Tizen. You want to go in Africa, which is the next really big market, especially after China, you need to target PWAs because there are mobile OSs that you don't even have heard of. And the only thing that all those OS have in common is the web. So if you want to target the next billion users, you're going to need to go on the web. That doesn't mean that native apps are going away, because there's nothing there's nothing more that we hate than a mobile web app on an Android or an iOS application, right? We're always looking for a native app, but the next billion users will have the web, and will have to make do with the web. And the last question about this talk is, why Kotlin? Okay, we had a very interesting talk about Rust, another multiple talks about React Native and all the libraries that revolves around it. So why on earth would we choose Kotlin? The first reason that's obvious is because it compiles everywhere, right? It compiles everywhere. It doesn't run everywhere like JavaScript does. It compiles everywhere. So on Android, it's a JVM bitcode. On iOS, it compiles to LLVM. And on the web, it compiles to JavaScript. The next reason that is very, very important in Kotlin is great tooling. Kotlin was created by JetBrains. There's a tooling support that you will not find on any other cross-platform language, especially not on JavaScript, since, you know, it's untoolable. And JetBrains has really focused their efforts on having automatic bridges. So we'll see how it works, but you can have really easily Kotlin to JVM, Kotlin to JS, Kotlin to C, Kotlin to Objective-C, and to Swift. Everything works seamlessly, and you know the language, and that's very, very important. If you're an Android developer, you know the language, but you're not the only one. A lot of other persons know the language. And choosing Kotlin is the insurance to use a large pool of developers, to be able to use your knowledge and to recruit people that can work in this language right now. So, we have decided to choose Kotlin. We want to make an application whose business logic, whose domain layer is entirely in Kotlin, so we can build it and deploy it everywhere. Now we have to make choices, okay? So these are the choices that I make for the application that I develop. These are opinions. Of course, these are not the only choice. These are not the only valid choice, but when you make an application, it's very important to understand how you're going to make it, what are the rules that you're going to use. And I choose to use dependency injection through a library that's named Codeine. Maybe you've understood that the company I created is named Codeine Coders, so maybe this is related. And I'm going to use MVP to separate views from presenters. I'm well aware that last year there was a talk here which was named, "Is MVP the most verbose pattern?" Well, I don't think so, but that's an opinion. Once again, everything that you see here is how I think that application should be developed. To me, MVP stands for Manageable Invulnerable Partition. Okay, I did my best to respect the letters, but what I want you to understand that is that MVP focuses on security amongst developers, okay, and partitioning, and that's very important. By using MVP, you ensure that there's this interface, this layer between your domain layer and your presentation layer. So we're going to use MVP, and we're actually working on a component that's called Codeine MVP, but as of now, it doesn't exist, so we'll use an ad hoc MVP that will take a few lines of code. We'll abstract the business code only, and that's very important because there's nothing that we hate more than an Android app that looks like an iOS app or vice versa. They don't look alike, they don't function alike, and we need to understand that. So what's important, if we want to hit the market right, is to have the same business layer, but to have tailored UI views so that we can reach iOS and Android where they like. So we'll have specific UI code. On Android, we'll use the native view system. On iOS, we'll use the native view system, of course, and on the web, we'll use React. Why React? Why not? This is an opinion. I'm not particularly inclined to choose React over Angular or over whatever else, but as it happens, JetBrains provides a layer of compatibility between Kotlin and React, which is named, surprise, Kotlin React. So let's use that. And we'll code everything in Kotlin, because we know everything works in Kotlin, and even Kotlin native, we can create an application, an iOS application in Kotlin through Kotlin native. JetBrains provides AppCode. AppCode has a Kotlin plugin, except this plugin hasn't been updated yet. So for this presentation, I am forced to write the iOS native views in Swift. Now, this is interesting, because if you work with another iOS developer, there are large odds that he will choose to remain in Swift, and that you will have to write the domain layer in Kotlin, and he will write the view system and the UI in Swift. So this is actually a valid choice. But remember that in a few months, you'll be able to write the entire iOS application entirely in Kotlin and have no line of Swift whatsoever. So how will our build architecture look like? First of all, there's native code, and that is no more opinion. This is how it works, how JetBrains has chosen to make Kotlin multi-platform work. So first, there's the common business code. And the common business code writes the domain logic. Okay, everything's in there. But sometimes you need to access network, you need to access file system, you need to access permissions, and those are specific to the platform. So we still need to write a few lines of code of actual implementation. The business code is in the common module, and the business code will expect some little things to be provided by the platform, and we need to provide this to the business code. And then we create an Android library, an iOS framework, and a web library. What's really important to understand there is that the common code is actually compiled multiple times. It's not an internal representation that is then transformed to Android, iOS, and web libraries. It's actually the common code that is compiled multiple times by multiple Kotlin compiler. Every time the Kotlin compiler reads the common code, the front end of the compiler is always the same, but the back end writes to bitcode, JVM bitcode, iOS native LLVM and frameworks, and JavaScript. So once we have all these libraries, we can create the UI code that is specific to each platform. Then we compile the UI code and the library for each platform, and that gives us the application. Okay, let's stop talking and let's show some code. Okay, so please notice that for the purpose of this demo, I'm running IntelliJ, Android Studio, the Android emulator, Xcode, the iOS simulator, and and QuickTime Player. What could go wrong, right? So, unfortunately, I don't have time to code in front of you, but I do have time to show you a multi-platform application. Okay, and we're not on the right project. Here we are. Sorry about that. Okay, so the first thing you'll need is to configure your application, and that is done via Gradle. Okay, Gradle, we either love it or hate it, but we have to use it. Here I'm using Gradle script Kotlin. The difference is that my build Gradle file ends with KTS, and the Gradle itself is actually in Kotlin. That's a new feature of Gradle, and if you love Kotlin, you should definitely try. It's great to finally understand what this Gradle file is about. For example, I can control click and it works. I still don't understand, but it works. Well, in this Kotlin Gradle file, what's important is that we use the Kotlin multi-platform plugin and that we added a bunch load of targets. Okay, we're going to compile our business layer for Android, for the web, and for iOS. But we are also going to compile our business layer for JVM, for Linux, for macOS. Why would we do that? Because we need to test. And if we compile for iOS and for Android, then we cannot run test on the JVM. So we need to compile the business layer also for JVM, so we can run test on JVM, also for Linux or macOS, whichever the host you're currently using, so that we can test on the native code that's generated. And the same goes for JS. I actually have two JS implementation, one that will use Node.js for testing, and one that I named WebJS that will compile JS for the web. The difference is very minimal. It will be the same JS, except, for example, when we need to access a file. When we need to access a file on the web, we'll use XHR. When we'll use to access a file on Node.js, we'll use Node.js internal APIs. And then we configure source sets. So for each source set that we configure, we're going to have a directory. There's already one source directory for each target. So that means a lot of source directories. But we can have even more. Why would we want to? Because sometimes there are common codes for specific targets. For example, all JVM tests contains codes that will run on all JVM targets, so the JVM itself and Android. And all native main will contain code that is used by the library on all native targets, so Linux, macOS, and iOS. So you can create intermediate source sets that will then be used by the source sets that are directly linked to the platform. For example, if I use the iOS simulator, I can say that it depends on the source set of all native main as well as all native desktop, and all native desktop is itself used by Linux main and macOS main. So you can create internal representation. Now, everything doesn't work as expected right now. At the moment, if you declare an internal source set, that internal source set will be understood by IntelliJ IDEA to be a common source set. So you can use native code, for example, native APIs or JS API, but the IDE will not recognize it and show errors, which is a shame. They're working on it. And as you'll see, there are little tricks that are in this build Gradle to mediate that. For example, the all native main isn't actually a source set that I defined, but it's a source dir inside the source set so that I trick the IDE. It's not optimal, but at the moment it's the best we have. Okay, and then Android doesn't really play nice with this build Gradle file. Why? Because Android compilation is a mess. It's extremely complicated, and they decided not to rewrite it, not to redo it, but instead to use it. So everything works fine in multi-platform, and everything has a nice API. But when we're using Android, we need to use also the dependency notation that Android uses. And then, of course, we configure a bit of publishing so that we'll be able to publish our libraries in a Maven. I'll use the Maven local. Okay, so the first thing I want to show you is this Kotlin code. I've decided to show you a Pokédex because why not? I wanted a JSON database, and it seemed funnier to use a Pokédex than a list of cities. So, the business module uses Kotlin. It's a library for dependency injection, and that's really Easy. We have 3 modules that we bind with. Some of them have interfaces, some of them don't, and we bind them so that we'll be able to retrieve them in the UI code when needed. This particular application has a Pokédex downloader that will be used to download and parse the JSON file, and 2 MVP presenters, one that shows a list of Pokémon and one that shows a Pokémon. Now, those presenters are really, really, really simple. The view interface is given a list of Pokémon, and maybe on the view we'll click on a Pokémon, so the view will call Pokémon selected, and the presenter will then call back the view by saying, okay, I validate, you can go to this Pokémon screen. Something really, really, really simple. The Pokémon MVP works the same, except its argument is, of course, the view, but also the Pokémon ID on which we earlier clicked. It's really classic MVP stuff. So you'll maybe notice that the presenter function return a job. That's because there are no coroutines on iOS. There are coroutines on Kotlin native, so you can have coroutines on Kotlin code that will be compiled to Kotlin native, but you cannot expose coroutine API to Kotlin to iOS. So instead of having suspend function, we return jobs, and if we want to suspend on it, then we'll use the syntax with job join. Okay, so we have 2 presenter implementations that are really, really basic. One displays a list of Pokémon that it gets from the Pokédex, and one shows a Pokémon in particular. Nothing really fancy. What's interesting is how are we going to download the Pokédex? So we ask the platforms to have a get Pokédex JSON implementation. So this is the syntax. We expect each platform to give us a Pokédex JSON function. That function takes a context, and what is the context? Well, it depends on the platform. Most of the platform won't have a context, so it will be an empty object. Android will have the Android context object that we need to pass through this function. So we also expect a class context to exist. The actual implementation of these classes needs to be on every platform. Why is it red? Because the IntelliJ IDEA is not yet intelligent enough to understand that the actual implementation of these functions are in intermediate source sets. Okay? For example, it tells me now that all JVM main, all native main, and all Linux main don't have the actual implementation. Actually, they do, in an intermediate source set. But IntelliJ is not smart enough. They, of course, are working on it. So we expect that, and then we will parse the Pokédex JSON. How will we parse it? We'll use a library that is provided by JetBrains, and which is called Kotlin X serialization. Everything that is under the Kotlin X package is actually low-level stuff that you can use in multi-platform, and that JetBrains is providing you for ease of use. And serialization is one of them, so we'll use that. And the great thing of serialization is that it doesn't use any reflection. Partially because there are no reflections available on JS and Kotlin native, so it's actually a compiler plugin that reads the annotation at compile time and that generates the code. It's a annotation parser and code generator, so it's extremely efficient. Now, we need to implement the actual implementation of the expected function. So, for example, if I'm going on the iOS source set, let's see how I did that. I did that with the iOS implementation that uses NSBundle and NSString. So it uses the NS bundle to load the JSON embedded source, the JSON embedded file, and then it reads the file and returns the string by using NS bundle. Now, what's really, really cool is that there is actually, code completion, which doesn't work right now. Okay, sorry. So yeah, you'll have to believe me, but for example, if I control click, I go there, and there are actually a lot of functions that mimics Cocoa. So you can program for iOS and have the exact same tooling experience that you've come to expect from JetBrains, right? You have code completion, you have, if I remove something, it immediately goes to red. If it gives me the name of the parameters, etc., etc. All the Cocoa framework is actually translated to Kotlin, and you can use it and have the exact same coding experience that you've come to expect from Kotlin. And that's amazingly powerful. They've just released it at KotlinConf 3 weeks ago, and I really encourage you to try, because after that, Xcode will feel extremely slow. If I do this in Xcode, it takes Xcode maybe 15 seconds before telling me that something might be wrong. Okay, and for example, if I go to Android main, you can see that no, not here. Where have I put this? I don't remember. Interesting. Okay, but if I go to JVM main, for example, I use a Pokédex JSON that will be embedded in the jar. So I use the JVM, JVM embedded file and the JVM API with R class Java get resource stream, etc., etc., etc. And for Node.js, you'll find that I use JavaScript API to access the file system module, etc., etc. Once I have all that, I can compile and I can deploy, right? Okay, audience participation, why not? Of course, the answer was wrong, but why not? And the answer is unit test. Please do test your code. And don't remember that different platforms need to be run for the same tests. Kotlin native, Kotlin JS, and Kotlin JVM all have the same semantic, but in a perfect world, you'll be able to run the test in only one platform and you'll be ensured of its viability. We're not in a perfect world, so we need to test on every platform. And that's why I've created a JVM implementation, a Node.js implementation, and a macOS and Linux implementation, so that we can run our test. So, how do we write test? Well, we write common test, right? The same test need to be able to run on all platforms. So it's in common test, and for reasons that are technical and not interesting, I need a few expect functions that are defined as actual in all test source sets, and let's test that I'm able to read a JSON file, for example, because I've used get Pokédex JSON. Is it working? Let's find out. So how about parsing and checking that a Pokemon that should be there is actually there. Let's test our presenters. The presenters will be the interfaces of our views, so we need to ensure that these views do work. So let's test all presenters and let's run tests. How do you run tests? Up, run. Okay, let's exit. Let's run the test. Okay, it's very little, but you'll see that the tests run on Android, on JVM, on macOS and on JavaScript through Node.js, so we can be sure. For example, now we know that all 6 tests that we created do run correctly on the JVM. Next, we know that the 6 tests do run currently on Kotlin native. And finally, we know that the 6 tests that we created do run on Node.js. So we have insurance of our business code. Now we need to export it to a library. This is very simple. We either publish to Maven local or we create an iOS framework. Then if I go to Android, all I have to do is import via Gradle this library, which is here, and create the activities that are actually views of the MVPs. And then we get the presenter here, and then we start the presenter, and then we wait to receive a Pokemon list and a Pokemon, and etc. Let's see if it works. Okay, it works. Yeah, I don't want to anger the demo gods, so let's say I hit this play button, it works. And what's interesting is that I display the information of a Pokemon in HTML. It's actually HTML. What I want you to understand is that in HTML is not inherently bad. HTML UIs are bad. HTML UIs, HTML-based interfaces are not a good idea. But HTML is still a very good way to present data. In this example, I could have created a bunch of views, text view, linked them, and etc. Or I could have, in the command code, a simple getInfo as HTML function that will be compiled to every platform, and I won't even have to worry about the binding of the UI. It's HTML, I can just display it. So HTML for data is a good idea. HTML for UI is a hell of a bad idea. So how does it work on Xcode? On Xcode, you have a framework. And this framework has an Objective-C header that is generated from your Kotlin source file. So, what do you need to do? Well, first you need to create a header that is called your library bridge and declare it in Xcode as a bridge so that it can generate a Swift bridge. So, what you need to understand is that Kotlin native bridges to Objective-C, and Objective-C is bridged to Swift via Xcode. So it's actually two bridges in a row, but that makes one beautiful and big bridge. Okay, and what's great is that I can have view controllers, Swift iOS view controllers that actually implement my view interfaces, my MVP view interfaces, because everything from Kotlin is bridged to iOS. Interfaces are part of that bridge. So I can say, okay, my view controller is implementing the MVP view, and I can get a presenter, and I can start it, and then I can implement the methods of that interface and have my view controller act as any other MVP view. Okay? The only thing that happened is that iOS is a very special baby. It needs extra care, and that extra care comes in this class, PokeBridge, right? Because Swift doesn't have the reified generics feature that Kotlin has. So in order to use DI, you need to create a bridge, because DI works with classes objects, and Swift cannot generate those classes objects. So you need a bridge for each object that you're going to take back from the DI container. And that bridge is actually really simple. Get the presenter, get the Pokédex. For each classes, you need to create an extra function. That's sad, but that's not the end of the world. And after that, you can very easily get that bridge. For example, in this application delegate, I create a new bridge, and from that I get the presenters, I get the Pokédex, I get everything that my application needs. And I get also, I get also completion, because it's actually an Objective-C file that is linked to Swift. So I get the same completion that I would have get for any other Swift interface. So it's really easy to use a Kotlin native framework in an iOS application. And finally, I talked about web. Well, let's see really quickly a bit of code. I use R components, which are React Native components using Kotlin React, and the exact same thing goes for iOS, Android, and the web. I have actual components that act as MVP views, and those MVP views get the presenter, and then I start the presenter, and then the presenter gives my view everything it needs to display. So we have the exact same functionalities because we compiled the business layer from the same source code, and we have different UIs that actually use the business code in the exact same way. So it's supposed to be a mobile app, so it's a mobile UI. You can select a Pokemon and it will display it after having downloaded the appropriate JSON. And this is a ugly React Native application, but a React Native application nonetheless. So we need to talk real quick about a concurrency model. In almost every language we know, a datum can be shared and mutable. And this has led to many bugs, to deadlocks, and to other crashes, concurrent modification exception, and etc. So this is a very erroneous model. So Kotlin Native offers a different model. Kotlin Native says that a datum can either be shared or mutable. There are no mutexes needed, because if a datum is shared between two threads, it cannot be mutated. Okay? This poses a lot of new functionalities, of new needs. Okay? So we need to understand about freezing. When a datum is frozen, it means it cannot be mutated and it cannot be unfrozen. As soon as it's frozen for the entire life cycle of the application, and it will not change, but it will be shared. This also poses the question of ownership. Which threads own which data? Because that data is only accessible to that thread. So this also poses the question of ownership transfer. Ownership transfer is, okay, I finished with this data, I can send it to you, and I won't access it anymore because I'm no longer the owner of that data. This is very close to what Rust does, okay? But this radically changes the way we program. And you need to watch this talk by Nikolai Igoti if you're going to do Kotlin Native, because Kotlin Native has a radically different memory model than JVM or JS. And you need to understand it, because you cannot work on Kotlin Native without understanding it. Know that this model will be backported to Kotlin in a distant future. Andrei Breslav, the creator of Kotlin, has announced that they are working on ideas on how to do that. It won't even be on Kotlin 1.4, maybe on 1.5 or 1.6, or they will eventually realize that it's undoable, but they're working on it. They want to backport this concurrency model to other platform that Kotlin is targeting. So we need to be prepared for that. So the question is, should you do Kotlin everywhere? After all that we've seen. Okay, so there are pain points, obviously. It's very young. And I've shown you that the idea shows false error. As of now, it's complicated because the compiler reads the codes multiple times. The idea does not, hopefully, because it would be very slow. And Kotlin native compilation time, as our Rust presenter very friendly shown, is a pain. And let's be honest, Kotlin native isn't stable yet, so you will encounter bug. But there are things that are there: Kotlin X coroutine, Kotlin X serialization, I/O, atomic foo, atomic operations, cater clients for network access. You can have common code for network access. There's Kotlin DI if you want to do any dependency injection that's common to all your platform. More are coming. We know that they're working on a common file API so that we don't have to make ourselves an actual file implementation. Kotlin, the company that I created, works on a bunch of new high-level components to help you to create quickly common application code, and more are coming. The community is actively working on it. A quick way on the Kotlin framework: it's a framework that's developed by the Kotlin Coders company, and its goal is to provide you high-level components to write shared business code. Okay, so we have, for example, Kotlin DI that's working, Kotlin DB that's in the work, and other components that are high-level, hence opinionated, but that will allow you to have high-level components at your disposal for very quick common application creation. And as much as there are pain points, there are joy points, okay, which are there. It's very young, so it's exciting. It's a pain point, but it's also an exciting time to do Kotlin native and Kotlin everywhere. And I've shown you that it works, okay? It's valid. Some applications are in production with Kotlin native, so it does work, and it is kind of stable. You can play with it. And you know, it's Kotlin everywhere. You already know and love Kotlin, and the community is amazing. In 15 years of open source, I've never seen a community that's as welcoming and as interesting as the Kotlin community. Just go to the Kotlin Slack and you'll have everything you need. So the question remains, should you do Kotlin native, Kotlin everywhere? Should you invest the time? And my obvious answer is, of course. Please give it a try. And now I'm happy to take any question.
So my question is this on the project you show, is it on GitHub?
Yes, the link is just down below. Salomon, Brys, KMP. You won't be able to compile it just yet. Give it a week, because it's actually using a version of Kotlin DI that has not been released yet. But in maybe a week, you'll be able to compile and run it.
We'll see it on Twitter, right?
Yes, of course.
Okay.
I was pretty surprised at the beginning when you said that the best apps should have common business logic, but different UIs for different platforms. Mm-hmm. Because on the very same day on a Flutter thing, we've heard that top-rated apps have the same UI on every platform. But
right.
Well, that's not the case. What I want to ask you is that, is Kotlin native some kind of competition to Flutter? And do you think these two tools try to achieve the same thing? Are they competitors? Are they one is better in your opinion or something?
Kotlin native and Kotlin everywhere is actually more comparable to Dart, okay? With the .vm or whatever. It's more of a business tool. Flutter itself is a UI toolkit, and there's no UI toolkit as of now that is written using Kotlin everywhere. I have no doubt that there will be. My opinion on the subject is that you shouldn't. Okay, for example, on an iOS application, this is the kind of toolbar that they're expecting at the top, right? And it's not material. And wanting to push material everywhere is a bit cocky, to my opinion. And that's just an opinion. I think that iOS, that you will have better reach on iOS if you use iOS codes, UI codes, and the same goes for Android and the web, but that's just an opinion. There are tools that do things like Flutter, and I think that if you want to, there will be tools that you'll be able to use for common UI. Now, JetBrains has explicitly said that they will not target Dart and Flutter with Kotlin. So let's hope for another tool, maybe React Native, for example.
I think that you can still use a Kotlin native framework from Flutter because there's a kind of interoperability, an asynchronous one in Flutter. So you can still write business logic and talk to it with Kotlin native.
Please don't do that.
So maybe that's just an opinion, right?
Of course.
Do you think about sharing the network layer with, for example, Kotlin Ktor, the recently released Kotlin
yes, actually,
API library?
Right now, I think this is the only multi-platform networking library that is developed. There was another, but they decided to stop in favor of Ktor. So I believe if you want to have REST API, Ktor's the way to go. And Ktor is for the server, but there are modules of Ktor that are targeted to clients, and you can use Ktor clients to make HTTP calls.
Thanks.
Thank you for the talk. It was very interesting. I'm an iOS developer, so it's kind of a good way to see something new. I'm wondering how, because code in iOS allows you to pre-test the app with the beta version of iOS and Swift. And I'm wondering if going with this, because some of the methods are kind of used in Kotlin, like in the code you showed us. Is it a problem here, or is it possible also with?
So I don't really understand your question.
Because you can download like a beta version of Xcode and a new Swift version and test your app, so you can see if it has and if it will have some problems later on.
Oh, okay. So actually, Kotlin Native creates a framework. So the app itself is written in Swift and uses the framework for the business logic. So it's a framework just like any other. There's no problems in trying a new version and using that same framework.
Yes, but like, do we need to wait for the update of this? For example, if the API changes for iOS, like NS file reaching files or something like this. Is it the new API will be available in IntelliJ in the code you showed us, or?
Well, I don't have the answer. This is very much to JetBrains. But do really Apple make breaking changes from one version to another?
Yes, even patch updates.
Okay, I'm sorry to hear that. That's really that really depends on JetBrains and when they will port. I believe that iOS developer is the next big target to Kotlin, so I think that they will be pretty responsive. Thank you all.